quiz is overwhelming, but this actually is the harder section. 6 and 7 is a little bit different. It's not factoring anymore. We're solving radical equations. Okay? So in order to solve radical equations, you have to understand restrictions on radicals. So the first thing you should know is we can't square root negatives, right? So when you talk about square rooting negatives, that's when we start having restrictions on the radicals. Like, well, if it's inside, pretty much there's limits of what we can put inside. That's what you need to be able to say. I can't put -1, I can't put -8, but I can put 2, I can put 0. Okay, so let's go ahead and just go through this one. We're talking about restrictions first. So, today on the standard, you have to be able to identify restrictions of radical equations and solve single radical equations today. Tomorrow we're solving the doubles. That's even crazier. Okay? So, but today we're staying a little bit basic with it. So, on the grid, sketch the graph of y equals x. So then we can, how do you do that? Well, let's just plug in values. 0 is 0. Square root of 1, 1. Square root of 2 is a decimal, square root of 3 is decimal, square root of 4 is 2, and then it just keeps going like that. I'm just plugging in x values to this spot right here and just calculating. But that's roughly what root x looks like. Okay? Notice there's nothing over here, and there's nothing down here, because I can't plug in a negative x, and whatever I plug in will never be negative, because when you square root something, it won't be negative. Okay? All right. That's what restrictions are, yeah. Nice, good. Okay. Do we have the domain range? Next question. State the domain of the graph, y equals square root. Domain. Domain, remember, domain goes with x. You have to know that for Math 30. Domain range is huge for the first chapter, so you won. Yeah. Okay, function relations, first chapter, Math 30. So domain goes with x. So what can your x's be? Well, look at this graph. Can x be 0? Can x be -5? Can x be +5? Yes. So it appears your domain is x greater than or equal to 0. It's all numbers bigger than or equal to 0. That's what your x can be. Okay. So for what values is the x in the radical defined? Same thing. Greater than or equal to 0. It's not defined when we try to square root a negative. That's an undefined value. We don't know what that is. Okay. Questions so far? Okay. Let's talk about b now. So now they threw an x minus 2 in there. Let's see, how does that change things? Well, on the grid, sketch the graph. Well, let's plug things in. If I plug 0 in, can I do that? What's 0 minus 2? And -2. Can't do it. Has to be 2 more now. Good. So if I put a 2 in, now I'm at 0. So this means essentially it moved over 2 spots to the right, which makes sense, right? I guess, sorry, you don't know this yet. But parabolas move opposite of what you see. So that says -2. Opposite of -2 is right 2, right? So this moves right 2, and it's the same exact graph. Just moves right 2, that's all.
So a negative is actually a...
Right. So if we change this to x plus 2, it'd be right here. Go the same direction.
Gotcha.
Okay, why? Well, think about it. Because if I put in -2 to this, what's -2 plus 2? 0. Boom, which is where we're at. So it's the shift, okay? The shift's not important right now for you guys. That comes later. But it's nice. Oh, nice for you guys to see that. Okay, so. All right, whatever. Okay. Of that. So now the domain changes from greater than or equal to 0 to greater than or equal to 2. The restrictions is the same thing. They're kind of showing you that that's the same thing. The domain is the restrictions. Explain how to determine the restrictions algebraically. Exactly. Did you guys hear that? Noel says find the number that makes the inside of the radical equal to 0. So what you do is set this x minus 2 real quick equal to 0. But inside the radical, actually, he's right, but I'm going to make it even more specific. We don't want it to be equal to 0. What do we want the radical inside to be? Positive, which would be greater than or equal to 0. So you just solve that inequality there real quick. All it is simply, look, add 2, add 2, you see we have exactly what we have written over here. That's all you do. Okay. So if it was like 2x plus 1, same thing. Take 2x plus 1, set it greater or equal to 0, solve for x. That's your inequality. Okay, we're actually going to do that one here in a second, I think. 3 minus 2x is coming. Okay. So right here, to explain, set inside greater than or equal to 0 and solve. Sorry, it says set inside greater than or equal to 0 and solve. That's what that says on there. Try to squeeze it in. Okay, we have one more function to look at, and then we're going to have some examples. Oh. Okay. So, consider our expression 3 minus 2x. Now, where this one gets tricky, it's a minus 2x, so the x now has a negative on it. Okay, so that does make things a little bit complicated. In this sense, it's going to flip us over. It's going to flip it over, going the other direction now. So why? On the grid sketch, well, let's just try some points. So let's try 0. If I put 0 in, I get 3, right? So square root of 3 is just a little bit below 2, so we'll say it's right about here. Okay, let's put in 1. 2 times 1 is 2. 3 minus 2 is square root of 1. Okay, and we can't put in 2, right? Right, if I put in 2, that's 4. 3 minus 4 is a negative 1. Can't do it. So that means the 0 is going to be right about here, which is 1.5. Do you see why it's 1.5? Okay, let's show you. 3 minus 2x, so I set that equal to 0. Minus the 3. Divide the negative 2. That's where the 3 halves comes from. So 3 halves is essentially the center point, and this time it's going less than. I'll show you why with that in a second. So 3 halves, and this is what the graph looks like. Okay, so why this direction? Why the other way? Let's go back. Let's just change this. I'll show you. Let's just change this right here to a greater than or equal to 0, right? That's what we said we wanted. Whoops. We said we want the inside of the radical to be greater than or equal to 0, correct? Okay, now look what do you do to an inequality when divided by a negative? Should know this from 9. Emily had a horrible 9 teacher in Emily. That was a bad year for you. Okay? Okay, just if you forgot, whenever you divide an inequality equation by a negative, you have to flip it. So this becomes less than equal, which makes the graph go the less than way. That's why it changes direction. Okay? So that's our restriction. X less than or equal to 3 halves. And we just did this. What's that? By a negative. Not just divide. Divide by a negative. No, by a negative. If you divide, it's fine. You can divide, just it's dividing or multiplying by a negative flips the inequality. Right. So let me redo this. I'll redo it right here for you. Some of you guys want to see it again. So remember, to determine the restrictions algebraically, you do this. You take the inside, you set it greater than or equal to 0, okay? Minus 3, minus 3. Do I flip? No. No, I didn't divide. Now I flip. So I take that, that's gone, so it's x less than or equal to negative over negative is 3 halves. Okay, Pearl, question?
Okay, so you know how I did the minus 3 on both sides? So
Yep.
that's just, so you just...
We're solving for x right now. It's a very good minor detail there. Yep.
Okay, and then you know how you did negative 3 over negative 2?
Mm-hmm.
So since it's dividing by a negative 2, that's why the inequality flips?
Because we divided one side by a negative to the other side, so we have to flip the inequality, yes.
Even though negative 3 divided by negative 2 will be a positive.
Right. That being a positive is irrelevant. The operation we did is divide by negative 2. That alone flips it. Doesn't matter what the output is.
And also, do we just take away the little radical thing?
Yes. For final restrictions, we just know that inside the radical, we want it to be positive. That's what this means.
So
Inside the radical, positive. Yeah.
Oh, so in the final answer, you don't have to rewrite the radical.
No. Because this means my x has to be less than 3 halves. So then the thing that's cool, guys, is you can test this very easily. What's the easy number below 3 halves to try? 0. Can you plug 0 in here and get a value? Yes. Can you plug 5 in here and get a value? No. So you know you did it right. So you can check both sides of your inequality to make sure you're facing the right way, too. Okay? All right? So this is hard stuff, so keep asking questions, guys. Some of you guys are really trying, and I see the brain really clicking. Keep it going. Okay? Okay, so radical equation. Radical equation which contains a radical. A value of the variable which satisfies the equation is called a root. When you solve the radical equation, you call those roots. They're possible answers. Here's the catch. Not all your solutions may be solutions. We have to check them. Okay? There's some that are called extraneous. And we'll, yes. Yeah, we'll talk about that. That's okay. You will now. You will now. It has to do with squaring and how, you know, if you square 2 and negative 2, you get both 4. So one of those actually works within the restrictions. So we'll get to it, though. That's hard to explain just quickly, but give me a chance, I'd say, Joel. Give me a chance. Yeah, just down the hall. So, algebraically determine any restriction of values for the variable of these radical equations. So all we're doing here is determining just restrictions. That's it. Not solving. We're just determining restrictions. So we just care about 4x plus 1. The 8's irrelevant. I just want to know restrictions. So this is all you do. That's it. 4x plus 1 greater than 0, solve. 4x plus 1 greater than or equal to 0, right? Has to be positive in the radical. So now you solve that.
So inside the radical, everything has to be positive.
Correct. Now what? Divide by 4. Do I flip? No. It's not negative. I didn't divide by negative. No, I'm selling it for everyone, not just you. Okay? So your first restriction has to be greater than or equal to negative 1/4. To test it, let's test 0. Should 0 work? Is 0 bigger than negative 1/4? If I put a 0 in here, I get square root 1. Cool. 0 worked. I have the right direction. I have the right value. Now, 2 minus 5x, what's going to happen to this one? The negative 7's irrelevant.
2 minus 5.
Okay, well, a positive has.
Good job. You have to flip. Why am I going to have to flip? I have a negative 5x, so I'm going to be dividing by a negative at some point. Yes. To mess with your restrictions. Our restrictions come within the radical. The radical is the thing that has problems. The radical can't square root negatives. So if you're lost right now, the main point is we can't have negatives in the radicals, and we're figuring out when that happens. We are figuring out when radicals become negative on the inside. And we're saying, nope, not that. So again, so look, we said 0 works. Watch. If I try, let's try greater than negative 4. If I try negative 1, right? Negative 1 is less than that, right? Negative 1, negative 4. Negative 4 plus 1 is negative 3. We have a problem. Okay? Negative 1, what's that? Negative 1/5 would work. Yep. Yep, negative 1/5 would work because negative 1/5 times 4, negative 4/5. Negative 4/5 plus 1 is a positive 1/5. You can do that. Okay? All right, so here's this one. So what do? Inside, greater than or equal to 0. Every time, that's what you're going to do. explain the 2 one, but you guys should be able to go do this right now. All of them have to be greater than or equal to 0. Why not just do that now? We'll go do them all separately, but the point is, every radical has to be greater than or equal to 0. We need to accept that. Okay, if you get those written down, let me know. We'll solve the B. For which one? Oh, we'll talk about it. No. Okay, so here we go. Minus the divide by a -5. Dividing by a negative. So you flip it. X is less than or equal to 2/5. Okay. These two are easy. We're gonna solve both of them. Just add 2, add 4, right? Plus 2, plus 4. Who thinks they know the answer? Well, you can't have 2. They're overlapping. Gavin. Not -2. Okay, so this is a tricky one. Let me explain. This is what it looks like. Right. Let me explain with the number line. So you have this guy that says greater than 2, and you have this guy that says greater than 4. You want the section that works for both restrictions. Now, don't think it's the overlap. That's false. Everybody says, oh, both sections. That's this one. No, because in here, doesn't work for the 4. So look, watch. If you say your answer is greater than or equal to 2, right? So 3. What's 3 minus 2? It's 1. Okay, we're good. 3 minus 4. So choose the one that covers both of them. So 4 is then right like this, you just need to tell me which one is the one that works. So greater than yes, those are what we're going to solve later in a little bit, and we're actually going to use those then. Yeah. Okay. So then, what is the answer going to be for that next one there for part B? Yeah, there's -x. A little tricky. So it's going to be -3, and then it's going to be x less than or equal to 3. So let's look at that. Here's 0, here's -2, here's 3. So this one's less than. Oh, and this one is greater than. They meet. So what do we want? No. We want in between them. They come together. Look, they come together. For when they go the same direction. Yeah.
Oh, so it's going to be the double sign one.
Yeah. Let's stay with this one. Let's stay with this one. You're not done with this yet. Which one? This one? So x. Okay. Shh. It's okay. Hold on. Let me hear a question first. It's okay. Let's stay up here asking questions. Fine. So she's just confused. Let's explain. So your two solutions was x greater than or equal to -2 and x less than or equal to 3. What you understand is that those go towards each other. And so they create essentially a boundary. I can only be between these two numbers.
So it's both?
Right, so it's going to be in between. How do you guys do in between the inequalities? You remember? You put the x in the middle. X is in between them. Okay? Again, guys, if you think you have it wrong, test. So try 0. Does 0 work for both of them? 0 plus 2, are we okay? 3 minus 0, are we okay? Yeah, we're good. Okay, now try 4. 4 plus 2, we're good. 3 minus 4, no good. Try negative 3. Negative 3 plus 2, we're no good. So you can knock, like, you kind of have options. It can be this section, or this section. Right? These ones don't work. This is the section we want, in between. The answer is between negative 2 and 3. This is the answer. Right, any number between those, yeah. But 0 works. 0 was the test. Okay, I know this is hard. Don't give up. Okay, this one here. 2x minus 7, so we go plus 7. So that's just simple. X greater than or equal to 7 halves. We have a negative x again over here, so that means we're going to be flipping again. Right, the 2 is irrelevant, the 3 is irrelevant. We only care about inside the radical. Okay. 24 over 5, you could write that as 4.8 if you want. 24 over 5 doesn't really matter, whatever you want to do. Okay. So, x greater than 24 over 5, and x, oh sorry, less than, I divided by negative. I didn't flip, guys. Where are you? Flip, thanks. Thanks to save. Flip. Okay. So, what that looks like on number line. Okay. 7 halves is 3.5. 24 over 5 is 4.8. So look, we're still good. It's in between. Because it's less than the 4.8, and it's bigger than the 3.5, so they're coming together again. So it's the in-between option.
So would it be 7 over 2 is smaller than x is smaller than 24 over 5?
Yeah, I like to write the x first, but I think you said it fine. That's cool. Did you guys see that? Recognize it. Yeah. Hey, take it easy. Yeah.
Actually, yeah, for sure. But like
All right. Okay, so let's see here. All right, we're going to have to stop there. Yeah.